Alright everyone, I wanted to shoot another quick video dealing with synthesis of a coordination compound and basically give you a quick overview of the procedure. We will do some demonstrations in lab when you arrive to lab to actually perform this experiment, but I thought it would be valuable to kind of give you an overview. I am hopeful that before you come, you will read the detailed procedure for this portion of the experiment in your lab manual. The procedure for synthesis starts on page 87 and is concluded on page 88. So be sure to have read this procedure carefully before coming to class. Procedure will begin with weighing recommended amount of copper sulfate pentahydrate. So go to the balances. The best way to weigh would be in a clean, dry 100 milliliter beaker. So place the beaker on the balance, hit tare to subtract the mass of the beaker, and then weigh the recommended amount. Remember what I already told you before, but I think it's worth repeating. You will be weighing an amount close to what's suggested in the procedure, and you'll be recording the exact mass you weighed on data sheet 1 to the proper number of significant figures. You don't have to weigh the exact amount recommended. Anywhere near that amount is fine. Once the solid is placed in the beaker, you'll take it back to your seat. You will add some water and you'll briefly heat the mixture of water and the solid on a hot plate, just enough to get the solid to dissolve. You don't need to boil it. In fact, boiling is not really recommended, just enough to dissolve it. Once substance is dissolved, you'll carefully remove the beaker from the hot plate using a hot mitt. Hot mitts are available throughout the lab. They're on sides of the benches. And then once the material has cooled a little bit, you will take the beaker to the hood where you'll measure and add ammonia to it. The color, once again, is expected to change from blue to purple. And then the goal is to crystallize the material to get the solid to form out of solution. To do that, you will employ two very common tricks that chemists employ to get materials to crystallize out of solution. First one is cooling. So there will be ice available and you'll be able to make your own ice bath in a large beaker, like a 600 milliliter beaker or 400. You'll fill it with ice, and then you'll place your reaction mixture of copper sulfate water and ammonia into the ice bath. This should be done in the hood. Ammonia should only be handled in the hood because it's concentrated. It's 15 molar. 15 molar ammonia is extremely harmful. If inhaled, it has a very sharp smell. It can irritate eyes, nose, and throat. So make sure to work in the hood with it. And then you will leave the beaker in the hood for a little while to allow some ammonia vapors to escape, to avoid breathing those vapors. And then once mixture crystallizes, you'll also, or as it's crystallizing, you'll also add a mixture of alcohols. There will be 50% ethanol, methanol mixture present in the hood. You'll measure recommended amount and you'll add it to your reaction mixture. Your product is not soluble in alcohol, and adding a solvent that your substance is not soluble in further reduces its solubility and allows the product to crystallize. As a result, you should see a layer of purple solid in your beaker, about maybe close to 1 inch thick. When you see that purple solid has formed, you will filter the material. You'll take the beaker back to your bench. You'll set up vacuum filtration, which we will demonstrate in class. And using vacuum filtration, you'll be able to filter out your material. Once filtration is complete, you'll add some alcohol mixture that should be chilled prior to addition to further to help with drying your product. And then when filtration is complete, you'll scrape the material out of the filtering funnel onto a folded piece of paper towel and spread it in a thin layer and allow it to dry. And while it's drying, you'll be starting to work on the next portion of the experiment, which is analyzing the substance for copper. So that's the plan.